So, hi everyone. It's really nice to see you again after 2 years of isolation and coronavirus. I know so many people I saw again after 2 years, and I remember that the last time I was on the stage here, we had a really big dream of Nuxt to extending from basically a SSR application to something that we can use it everywhere and something beyond it. So you can use the same tooling to build your servers. You can use it to make your website applications, and all working great together. And we can have some combination ideas on top of it. So after actually 2 years of pursuing this dream, and well, to be honest, it was a crazy idea because we basically had to rewrite everything. We had to create some things that was impossible in JavaScript ecosystem. And here we are. After 2 years, this is something that we can be proud of, that's something that is almost ready to production. And yeah, it gives really great stats. Before going towards the Nuxt tree, I would like to start with some introduction of Nuxt 2. And we can see that in Nuxt 2, how the server integration was working already, what was the benefits with it, what was the limitation with it, and yeah, basically why we had to start a project called Nitro, which today is part of the Nuxt tree. So in Nuxt 2, we had a concept called server middleware. If you're familiar with the term of server-side rendering, you can create a Vue.js application that can exactly run the same behavior on the server side. And using this behavior, we can have faster performance because when the website is ready, we can already see the results without executing JavaScript. But because of this opportunity, because we already have a server in the backend, it's obvious, it's no-brainer that we can already extend this server. We can add our APIs to the same server, and we can have something small to work together. So in Nuxt 2, it wasn't very hard to add a server middleware or an API route. All we had to do was to create a file inside any directory that we want. The signature is something similar and familiar to you, probably if you already created a Node.js server. And basically, with this signature, we can respond to a request. And to register it, there is also a shortcut. So basically, for every possible server API we had, we could just specify it in the Nuxt configuration. And it's not that much complicated. I would say it was also sexy. So we had it so far. And it works great. Just by having one file, one line of the configuration, we can already have an API endpoint. It's plain and simple. We already had TypeScript support with it in one of the releases of Nuxt 2, thanks to the GT. And we had also a basic router system using prefixes. But it has some limitations. So first, we couldn't have a dynamic path in the routes. If you want to have something like a hello name and the name part of the route is dynamic, we couldn't support it in Nuxt 2 because it was super simple. The other problem with that is that these files are really loaded in the runtime. So if you are deploying your application somewhere, it's not bundled. We have to actually deploy entire source code of the application to the production in order to make it working. Because it was simple, in Node.js we don't have things like aliases, we don't have support for branches like GraphQL, and this was kind of making it basic. We couldn't add more and more features on top of it, and it was a little bit different than the other files in your Nuxt application. And there is also one thing about frameworks that are based on the middleware system is the global performance. Because for every request that was coming to the clients, actually, it seems to be like a prefix, but every middleware is getting run on the runtime until we find a match. And so for majority of the requests that was not API request, we have to still hit this endpoint. And to have a closer look into how it was working in Nuxt 2, actually, Nuxt is using an older version of the Express called Connect. Connect is also lighter. And on top of this Connect server, Nuxt has an isolation for server-side rendering. So every code that you write in your application, plugins, the components, everything else, is bundled through Webpack or using Nuxt Bridge using White. And this SSR bundle is loaded in an isolated environment, so it doesn't have any side effects if you reload your application in development mode. And this server is running on some site with hot module replacement support. And server middleware in Nuxt 2 are actually in the same process of the Nuxt Node.js process that we are running Nuxt dev. It seems to be easy. It seems to be super simple because we don't have any overhead with it, but it comes with the limitations. And also some probably not the best practices that was introducing with this simplicity. Sometimes simplicity is not that easy. You have to rethink about how you make it something simple. And yeah, it was super simple. You could support TypeScript support for it. For invalidating cache, when you are was updating a file during development mode, you was updating a server route. We was invalidating a common.js cache. And it came with its complexities because sometimes you import another file from one file. And last but not least, node modules. Everyone is familiar with it. It's like a hill. In order to deploy an application via server middleware of Nuxt, we had to deploy entire node modules, which is not the best. And this runtime is also kind of different in production as well because of the isolation. In Nuxt, we also had one more possibility almost from the beginning. You could use Nuxt not only as a standalone framework, you could use it as a middleware for your own existing application. You could use it as a middleware to an Express application, using it for Fastify, for Happy.js, for anything else. And it involves a little bit programmatic usage for initiating a server, loading the programmatic API of Nuxt. But it was kind of the experience. This gives lots of flexibilities, but also came with its own downsides. First, again, it needs node modules entirely to deploy to the production. So for things like serverless environments, which have limitations, it was making it hard. But more especially for other environments like edge rendering, which are workers, it was completely making it impossible because you cannot deploy a node application with node modules to edge. And HMR of the server was not easy because you had to reload your server every time you was changing a file. Sometimes it's giving unpredictable behavior because Nuxt was designed to be used in some way, especially things like loading a screen, the WebSocket support. And with this freedom, you could do everything inside the file, and Nuxt couldn't predict it. And of course, it's making the code more complex. We wanted to make Nuxt application as easy as possible. If you want to see how the cause was working, when you was like in your application trying to fetch something from the server side, some really strange things happen. In this example, we are assuming that we are loading a product page in a web shop. And in order to server-side render this endpoint, we have to fetch some data for the product, obviously, from the same API that is living in the same server. And yeah, for doing this, you have to just jump over the same server, from the same server make a loopback call, and fetch data. This has some benefits because we have a shared server. We don't have to create a server for the API and one for the server-side rendering. But it also comes with some downsides. First of all, if you probably are already familiar about the base URL handling, it has to be manually configured or through modules like Axios module that try to make it easier, but also introduce many edge cases that it wasn't working as expected. Because of this round trip, we are adding lots of overhead. Usually there are some benchmarks of the frameworks, like you say, OK, we use super fast. But as long as we go to a real-world application, we add some actual endpoints, this latency starts to show up. And we can see, OK, Nuxt isn't fast as I was expecting. And the reason was that there are these latencies. And especially with external API endpoints, it can grow up for each request. Imagine like 20 milliseconds. It really matters because usually for the pages in real applications, we have to make few API calls for each rendering, and it can just add up. And with Parallels, it can really slow down the application. And this was actually one of the main blockers of the performance in Nuxt 2. And on top of all of this, in Nuxt 2, we didn't have a built-in HTTP client. There was some, and there are probably some super popular libraries like Axios for making this, but it was never an official integration, so it was always tricky to configure it. And Nuxt also had always a really unique feature called static site generation. And this feature in Nuxt 2 was allowing to generate the whole application to be fully static and not depending to the server files, and we could deploy it everywhere. In Nuxt.2, when we initiate the Nuxt generate command, it first actually tries to start bundling the whole application with some specific environment to tell the code behave in a way that it's expected to run on a static environment, so it doesn't make any API calls. It has special considerations. Nuxt is, when you use Nuxt generate, Nuxt loads this bundle using a programmatic API to actually emulate a server. And using this server and an internal API, Nuxt tries to render each page one by one and write them to the file system. And this is ready after that. This was one of the unique features of Nuxt.2 so far until today. It was super inefficient with the recent addition of crawler that Sebastian worked on. And full static support, we could also remove the server dependency entirely. So any dependency on the server, any calls could happen just once during the build. And after that, we could just forget about the server. And there is also a feature in Nuxt.2 that you can use a shared cache between the pages. But there are also some issues with that we wanted to solve and improve it in Nuxt.3. First, the thing is that you have to always choose between a server or a static application. Well, there are many cases that you can choose between one of them. Imagine you have a really big commercial website, you have some static pages like About Us, you have some blogs, and you have some real pages that you want to change them on demand, like user's profile. And combining these patterns was never efficient. You had to choose between them, and you had to sometimes use client-side tricks to use a static application with some dynamic content. And yeah, we could make it better. We can see later on. And generation on demand is something that is trendy after in past year probably. It's a shift towards static and servers to something shared that we can have best from the both worlds. And instead of spending entire CI time, imagine you have like a big website with many pages, thousands of pages, and each time you deploy, you make any style CSS improvement, the CI/CD has to pre-generate all of the possible pages. So it was slowing down, actually. We was using the static generation for saving our time, for saving our money, but it was a counter pattern. And with this architecture, we always have to pre-generate and predict every possible page that we want to generate during the deployment, which is making it a little bit slower. And this direct rendering method used in Nuxt.2 was making also the internal code more complicated, which was making some improvements harder. We can see in the later slides how it was. And finally, it is, if you want to deploy an actual Nuxt.2 server to production with server-side rendering, it seems to be easy, but it's also big. It's not efficient, because for a real deployment, we still was depending on Nuxt configuration. Sometimes there are configurations that are meant for the runtime, and we was reading them from the same Nuxt config. Sometimes we also have a custom server entry, like we saw earlier with Express. There is a .nuxt directory that you are probably familiar with. There are temporary generated files inside it and the bundles that are required for production, but that's not enough. Especially if you have a server part and integration in your application, you have to ship the same source code to the production, because as we saw, it's not bundled. It needs to be deployed to production with the same format. We have to deploy the package JSON, and also during the building process or in the runtime, reinstall the same dependencies again to replicate the environment that we are expecting, and of course, thousands or maybe thousands of the dependencies in node modules. Well, it wasn't efficient. We tried our best, created also a special package called Nuxt.start with less dependencies, but shaking node modules is a no-brainer that we had to introduce, which comes to the next thing that we wanted to improve, Nitro project. Actually, Nitro project was started like 2 years ago, I guess. It was a team meeting with internal team meeting, and we was just discovering something about Cloudflare workers. And during the meeting, I was curious, like, shit, Nuxt is not good. I just want to throw it away. I want to start from scratch. But that time, we was still actively working on Nuxt.2, so we couldn't throw it away. And Nitro project actually started as an experiment on top of Nuxt.2, thanks to the modularity it has and the hooks that it provides. We could manage to create a proof of concept to deploy a Nuxt application to Edge and Cloudflare workers, and removing probably most of the limitations that we had. But it was almost the beginning, because proof of concept is an idea, but in order to make it a real-world use case, in order to solve every possible requirement, there was many things that we had to do, and it finally ended up creating an organization called on.js with so many small projects that made it happen. So what is Nitro? Nitro idea is simple. It's probably a little bit more eager, but it's finally possible. Nitro's idea is to create any JavaScript server from any possible framework that you can imagine. It can be React, it can be Nuxt, it can be Vue, it can be only a pure server like Fastify or Express, and deploy it everywhere. So imagine you can use every possible NPM dependency that is meant to be used for Node.js, but you can deploy it everywhere, including Edge. It's a little bit ambitious, I know, but and it's hard to believe it's possible, but today it's almost possible that we can deploy any possible framework to anywhere, including your browser service worker. Yes, you can actually run Express in your browser service worker using Nitro. It provides and same DNA and shares the same DNA of the Nuxt with the simplicity, with the same experience that it has. And it's the core engine and server engine for the Nuxt tree to make it clean as possible. It provides the same rapid development. It has auto-discovery features, so you don't have to configure the files like the server middleware you saw earlier by yourself. Just like the pages, they are auto-discovered. It supports different providers. It's completely agnostic, so it's not meant to be deployed in like AWS for sure, like a framework for AWS. It's a framework for every provider. It's portable and compact, so the builds that are Nitro generating, they are not depending on anything, including node modules or your configuration. It's completely independent. It has routing features. It's especially designed to be as minimal as possible, so we try to remove every consideration we had, move it to the Nuxt, and keep Nitro as simple as possible. So if you have any idea, you can just apply it and use Nitro without any dependencies. Nitro has a special feature called server-side code splitting. You're probably familiar with the code splitting and the benefits that it has for the client side. And in a browser, when users load a page, you expect some entry point to be loaded, but you don't expect that every possible chunk and every possible code for other pages to be loaded. And Nitro is moving the same idea to the server side. Usually frameworks took a different approach. Frameworks like Next.js, they started to create multiple lambdas for different routes. But it's not efficient always, because you have sometimes shared utilities. Imagine you have a big backend application. It has some big utilities. And you can already reuse them between these API routes. By splitting them, not splitting them, and using same bundle and lazy loaded chunks, we can have best of the worlds. Actually, we can have one entry point, so it's almost fitting to every deployment. Actually, Chris, just before my presentation, was mentioning about limitations of AWS Edge, and I was saying no, and it's okay, because why? We don't have any, like, we only need one entry point, and this one entry point can be smart enough to lazy load its chunks. And by this lazy loading, we can reduce code start time as much as possible, but we can also improve it over the time, because when one of the instances is hot and loading the entry point chunk, we can actually reuse it for the rest of the chunks instead of initiating again and again for each other chunk. So it's kind of one of the unique features of Nitro. Nitro has full TypeScript support. Thanks so much for Daniel's help. And you can see the developer experience that it's bringing. Not only the code is written in TypeScript, but it has fully integrated TypeScript support, which just brings to your code. Nitro has a unique storage layer, and this storage layer of the Nitro provides a way to move away from the FS API to one API that can work everywhere. Imagine in a service worker, you don't have any file system access. And let's make it also beyond that, which we can see in the future. It also provides a caching API that we can also see. It's super hackable. Actually, any preset in Nitro is also a configuration. So it's basically meant for be hacked, and it's meant to be integrated into Nuxt framework. We almost have like no hacks in Nuxt, because it's basically a Nitro preset that's powering Nuxt without any special considerations or code blocks in Nitro that is meant for making it for Nuxt. It also has a great feature called auto-imports. You probably saw how it works. Basically, it removes importing requirement. It's smart enough to detect what utilities you are using. It imports them in the right chunk, and it reshakes them. Same as Nuxt. And it's backward compatible, which is probably one of the most exciting and unique features of Nitro. It's not throwing away the entire NPM ecosystem to just be compatible with edge functions. It's actually trying to reuse them by emulating Node.js layer and emulating the common libraries. So it magically converts any Node.js library to something agnostic. In Nuxt 2, in Nuxt 3, it is all you have to do to create a server route. You have to create server API hello.ts or any extension, and you can just create a normal function that returns an object. And now you have the API. Isn't it easier? Isn't it also similar to Nuxt, how you was expecting a pages work? It's just done. And it's done with all of the benefits we have with Nitro. Also, it has a first-class integration with the runtime application. So instead of installing another module like Axios, instead of configuring your endpoints, it's just working out of the box. The API is powered by a framework called H3. It's a new framework that we had to create for a Node.js agnostic HTTP support. And it's something super lightweight. It's probably one of the fastest frameworks in the world. You can see the benchmarks. And it's basically built on top of the TypeScript. It has no dependencies, like the legacy ones that Express has. Some of them are created like 10 years ago or even more. Internally, several routes are using radix trees, and the library name is ironically radix tree. And these radix trees are smart enough for matching a route without iterating over them one by one, which is super fast, faster than Middleware system. And it's used for matching the server routes. And as a result, it also brings the dynamic route support. As you can see, there is an integrated HTTP client attached to. We can directly use useFetch or Fetch API or DataSign Fetch for more convenience to be just returning the parse response. And it's all built in, and it's already configured for you. The output of this API is platform agnostic. You can write the same code, expect it to be run on any platform. So you can change your mind later on. It's not that you start with the framework and you are locked into the vendor. And on top of it, H3 ecosystem is providing some utilities for like common things like setting a cookie, setting up some headers. So you don't have to write anything from scratch. And we are adding more and more functions to it. If you remember, the API ecosystem in Nuxt 2, we had to make a round trip, but it's no more in Nuxt 3. Actually, the same server entry point that I was talking before, that is using lazy chunks, is smart enough that when you are fetching in the server environment, it directly calls the server functions and emulates the entire HTTP stack. We actually wrote the Node.js alternative HTTP module from ground up in a project called onenv. And it actually makes it possible to make direct HTTP calls. This way, we actually remove every latency. So instead of few milliseconds, it's 0 latency. It's just like in calling a function in the server side. We are no longer have to be worried about the base URL because it's even not relevant in the server side because there's no base URL. And the fetch experience does improve using OhmyFetch project. Still, you can use the standard fetch spec or your custom library that is built on top of it. Comparing the architecture between Nuxt 2 and Nuxt 3, if you remember, the server entry was outside and server middleware was outside of the bundle. In Nuxt 3, they are integrated into the same bundle. When we are building the application using Vue or Webpack, it's its own bundle. In an isolated worker, Nitro also builds the tiny chunk that is required for the Nitro during development mode. It's like a few hundreds of lines, which is super fast to be generated. And it's integrating all of them into an isolated worker. This way, we don't have any tricks for isolating the server-side rendering during development mode. We are not leaking any node modules state between reloads, so we don't have memory leaks anymore. And most importantly, server is built and bundled in the same environment of SSR. This almost solved every problem we had in before. Well, it came with one small gotcha. Well, I mean, with every iteration, we have some new limitations. Many modules in Nuxt ecosystem was unfortunately having some assumption that several middleware are running in the same context, and they have direct communication. With this new architecture, modules have to provide everything that is required to the runtime using either visual templates or runtime configuration, and they have to just not depend on it anymore. So this way, we can get rid of entire node modules. We can get rid of the Nuxt config. We can get rid of the runtime overhead, and we can completely make this sandbox something similar to the production without making any changes. Nitro also comes with something more exciting called Pluggable KV Storage. It's powered by a project we created as well called OnStorage, and the idea is to make every considerations of file system agnostic. We are not depending on FS module anymore. And using OnStorage project, you can actually, similar to if you are already used Linux, you can mount any possible path you want to use in the production and just depend on these paths in production. It's basically created in a way that you can deploy your application wherever you are and wherever decision you make to each platform you like. And you can also change your decision later on. For example, if you want to optimize your application in actual production to support Redis, it's just a configuration. You don't have to tell every developer to install Redis on their environments, and God knows in Windows how you can install it. But it's making life easier. Developers can start instantly with your application. They have a state, and you can mount any possible endpoint you want. You can combine different ideas. You can even split your caching system into different providers. You can also write your own caching system. And it's also going beyond that. Because also in the browsers, it can support local storage. By default, we can support file system in Node.js environments. And yeah, you can also write your own custom driver. Actually, we are using it extensively in content module with two a little bit more advanced features called overlay storage, which you can combine two storages together. And another advanced feature that is called bundle storage, which during the build time, we can persist some state like a file system. We can move it to the bundle of production and load it, regardless of the platform. It doesn't matter which platform we are using. We can emulate a file system, which every file we are expecting to the production. And this storage is also powering some new APIs. I'm quickly iterating over this example. I will share for sure my slides with you. You can see the URL. That's my Twitter account. But here's how we can create a simple application. No configuration at all. No extra files at all. And this works fine. You can create a note-taking application with the backend. In the first example, we are counting the number of the keys to generate a new ID. We use useBody, which is a H3 helper to read the request body. We're creating a node, saving it, and done. And just to be sure, there is no other imports. This is not an example, because all of these just are auto-imported. And to use it, you can use event context to read request parameters. If you can see the server file, it has an ID, dynamic part in it. That's how you can access it. You can retrieve the node. You can create an error if the node is not found, and if it's found, just return it. And by returning, it's signifying the node and sending it with the right content type to the client. Nitro also comes with something powerful called a caching layer. Caching layer is basically built on top of the storage layer to be fully agnostic, to work in any environment. And it has some very interesting features. First of all, you can introduce a stateware revalidation to each possible route. This means that when one user hits the route, we show the result. If the next user is requesting the same route, we show the old content, and in the background, we update it. It increases the benchmarks by something like 100 times, sometimes more. And it's not magic. It's basically because we are efficiently using a cache. We are using a very short amount of cache, even 1 or 2 seconds. And using just 1 or 2 seconds and combination with a caching system, we can have a shared caching system that, for example, can use Redis. It's distributed, and it can speed up your application. It's also possible to use the same caching layer for more low-level implementations. For example, if you have shared function that is not an API route, we can also cache it. And with an upcoming feature that is called hybrid rendering in Nuxt.3, you can actually define these rules for a group of the paths. So, for example, if you want to cache entire block, if you want to cache an entire subsection of the API routes, we can just define it in the configuration, and Nitro will take care of the rest. It can add the runtime logic that is required for this caching. And as you can see, the deployment in Nuxt.3 is now much easier. When you use Nuxt build, it generates a super portable output directory with required public files, a tree-shaped version of the node modules. It's not node modules, it's just the dependencies that are required with the same structure, and every possible server chunk that is required. And yeah, depending on the platform, as Sebastian showed you, it might differ. For example, for Cloudflare, we are not generating node modules. We use a more efficient bundle, but it's all true of the Nitro. You don't have to, by hand, generate these files. Comparing Nuxt generate between Nuxt2 and Nuxt3, in Nuxt3, pre-rendering is the new term. Not only works using Nuxt generate, but also part of the Nuxt build. And you can this way use pre-rendering. And there's also one more architectural difference, which seems to be small with the fetch, but it has great impact for the future because we are depending on native fetch API. We can have more advanced possibilities, such as crawler hints. We can say the crawler, please crawl more pages for me. Please crawl some images for me, which was a little bit hacky in Nuxt2. And with this new hybrid rendering system and architecture, we can move beyond static or server to have something that is best of the both worlds. One good news is that Nitro first was started based on the Nuxt. Actually, it was meant to be used for Nuxt, but we finally decided to make it completely open. So if you have any custom idea, if you have your own framework, if you want to create a React application, I don't want to do this, but you can do this. You can use Nitro already. And there is a core concept in Nitro and Nuxt since the beginning. We always believe in the freedom. We never meant to create a framework that is used for specific platforms and optimized for them. Nitro is always open to accept any new platform, any new partner that we want to add, and nothing is considered there. So if you are interested to add your own custom storage system, if you are interested to add your own custom hosting system, it's always open. We actually accept new presets, and we are keeping to add more and more presets to the Nitro to make it open as much as possible. This way, you never have to be vendor locked in. When you choose Nuxt, you are always free to also change your decisions, whether you want to change the internal stack or if you want to deploy to a different place. You're always free. You don't have to spend time, money, and to just refactor your code to make it ready for another platform. You don't need to learn about something new, like how AWS is working if you want to deploy to AWS. It's already automated. This is probably the beginning of Nitro. We have some great plans for the future of Nitro. One of them is route rules and route caching, which you saw earlier for the caching specific feature. But it goes beyond that. You can also use it for converting your Nuxt application as a reverse proxy. It can do the rewrites. It can do things like redirects for us. And most importantly, because of the architecture of Nitro and because we have an abstracted API, we can integrate it with the native providers. So if a provider is natively supporting proxy, Nitro just configures your provider to use that proxy. No anymore runtime. Another thing is server functions that are coming to Nitro, making API routes to another level. You can just API routes like a normal function. They are automated cached, and TypeScript support is much better for them because we can predict input and output of a function better than an API. WebSockets, that is one thing that we are working on currently to have a shared WebSocket API, make it super easier and also platform agnostic. And WebAssembly is probably one of my favorites. I'm looking forward to see it because this way we can go beyond JavaScript. Not only we can support WebAssembly libraries, we can on-demand compile them. Imagine you can have some C++ file in your application for something that is super optimized, and it can be deployed everywhere without any configuration. All is handled by Nitro. This is our core concept. It's something I dreamed, something someday we can achieve fully. is that I dream that all of our efforts in the ecosystem, with Vue ecosystem, with React ecosystem, and JavaScript ecosystem to be someday united. And this is something that we are fighting for, honestly. Thank you so much. I think my talk took a little bit longer. There are two really great talks, one from Daniel after the break about the experience of Nuxt, and one tomorrow by Lucy, which I for sure recommend you to see it, about the other power of Nuxt using modules ecosystem. Thank you so much.